Good morning, Overall Middle School students. This is Mr. Woolley, and today we're going to work on Lesson 8, Representing Proportional Relationships with Equations. So we're going to teach you a few skills there you might remember from last year with equations and stuff, so hopefully you can follow along as well today. All right, now remember, proportional relationships do have that constant ratio, or what we call a unit rate. And that constant ratio or unit rate, which we keep getting by y values divided by x values, can also be called the constant in proportionality. All right? So there's a few different names that we'll be using this. Unit rate, constant of proportionality, our k value. They're all the same thing. We all get them by taking a y value divided by an x value. All right? And what we're going to do is show you how we get this equation built from this today. We get our k value because we do a division problem, some type of unit rate, a y value divided by an x value. But if I multiply both sides by x in this equation, k times x, and this side times x, these eliminate each other, all right? It ends up being like an x divided by x situation. And we get the equation k times x equals y, or what we'll be seeing a lot, y equals k times x. That equation is going to be super, super important. A y value equals our unit rate, or constant proportionality, or k value, times x. All right? So y equals k times x is a basic format we're going to use over and over again. All right, so here's our problem. Do we have enough gas to make it to the gas station? Your mother is accelerated onto the interstate beginning a long road trip, and you notice that the low fuel light's on, indicating there's a half gallon left in the gas tank. The nearest gas station is 26 miles away. Your mother keeps a log where she records the mileage and the number of gallons purchased each time she fills up the tank. Use the information in the table below to determine whether you'll make it to the gas station before the gas runs out. You'll know that if you can determine the amount of gas that your car consumes in a particular number of miles, you can determine whether or not you can make it to the next gas station. And here's Mom's gas record. An X column and a Y column in a table here. 8 gallons, she can go 224 miles. 10 gallons, 280 miles. 4 gallons, 112 miles. Well, on A, when I want to find that constant proportionality, I divide. 224 divided by 8. 280 divided by 10, 112 divided by 4, and I keep getting 28 miles per gallon. So my k value, my unit rate, or constant proportionality, is 28. Now how can I put that into an equation though? We're always going to start with that y equals k times x. And the unit rate we just figured out gets popped right in instead of that k. So from k, I just put the 28 in that place instead. Now our challenge is to figure out, what am I going to switch the y into? What am I going to switch the x into? All right? Now, I want to replace them with a meaningful variable. So the y in the y column stood for miles driven, so I'm going to use m. And my x column stood for gallons, so I'm going to use g. So that's why you see that the y turned into an m and x turned into the g. So m stands for miles equals 28 times however many gallons of gas you have. C. Knowing that there's a half gallon of gas left in the tank when the light comes on, will she make it to the nearest gas station? Well, no, because she can only go 14 miles, and she needs to go 26 miles. Because remember, she can go 28 miles per gallon, what we just figured out up here. So she can go 28 miles on 1 gallon of gas. Well, she can go 14 miles on half of a gallon of gas. Just cut it in half. So she's not going to be able to make it. Now, I can use that equation to help me find some answers. Using the equation found in Part B, determine how far your mother can go on 18 gallons of gas. All right, so 18 gallons. Well, G stood for gallons. So 28 times 18 should tell me how many miles I go, and that'll give me 504 miles. E, I'm going to use that same equation again. Remember, I got it from the y equals kx format, and I turned it into m equals 28 times g. So this time I know the miles, so I put that in for the m. And then 750 equals 28 times g. Well, I want to get the g all by itself. So instead of times them by 28, I divide by 28. And I have to do that on both sides. So that eliminates here. There's no more 28 left. And 750 divided by 28 gives me about 26.8 gallons. All right. Next up, we'll have another sample problem for us. Andrea's portraits. Andrea's a street artist in New Orleans. She draws caricatures, cartoon-like portraits of tourists. People have their portrait drawn and come back later to pick it up from her. The graph below shows the relationship between the number of portraits she draws and the amount of time and hours she needs to draw the portraits. Now what I did was I highlighted wherever my line crisscrossed exact grid lines. So right here, it was going to cross here exactly. Right here, it crossed some grid lines exactly. Up here, it crossed grid lines exactly. I didn't want to put it like right here or something because I didn't cross like an intersection at grid lines very good. So only when I hit the good intersections. Now those point locations are at 2, 3, 4, 6, and 6, 9. Like for example, 2, 3, how do I get that? Well, I start at the origin, I go right 2, up 3. That's how I do that, remember from last year from graphing. So anyways, what's that mean? Well, if the x is 2 and the y is 3, it means 3 portraits can be drawn in 2 hours. I kind of follow what the labels are in the graph. Now, we're going to go ahead and build an equation, and it helps to do this part first. I'm not sure whether I have it reversed, but if we want to figure out that constant proportionality, which I'll need to do up here in that equation, I can take any point on the graph, if I go back up here, and take a y value divided by an x value. 3 divided by 2, 6 divided by 4, 9 divided by 6. Either way, it's going to give me 1.5. Now I'm going to use that as my k value. So I'm going to find that k value, which I use by division, and then remember y is going to equal 1.5x because the k stands for 1.5. So now I'm at this situation, and since the y is talking about portraits, I'm going to use a p for portraits, and since h stood for time, or the x was the time, I'm going to use an h for hours instead. So p equals 1.5h. Try to make it something worthwhile that makes sense when you fit it into the equation. All right, we got a few problems here. We want to write an equation and then hopefully get it into something that'll make sense to us. So there are 3 cans that store 9 tennis balls. We want to find that constant proportionality for this situation. Well, we're trying to find the number of balls per can. So 9 tennis balls in 3 cans. There's my y value on top, my x value on the bottom. Divide them, you get 3 tennis balls per can. So my special number is going to be a 3, my unit rate, or constant proportionality, or k value. Now y stood for tennis balls, so I'm going to use a t. X was cans, so I'm going to use c for cans. So t equals 3 times c. So tennis balls equals 3 times the amount of cans you have. Number 2, in 25 minutes, Lee can run 10 laps around the track. Determine the number of laps he can run per minute. Well, our constant proportionality is, remember time always goes on the bottom, so my minutes are me down here. 10 laps in 25 minutes. So 10 divided by 25 is 0.4 laps per minute. So my y equals kx format. The 0.4 got replaced right there with the k. And then y stood for laps, so I use an L. M is put in here because the x value is minutes, so I'm using m. So laps equals 0.4 times however many minutes you run. Next up, Jennifer's shopping with her mother. They pay $2 per pound for tomatoes at the vegetable stand on a constant proportionality. Well, I kind of gave it to you already. $2 for 1 pound is $2 per pound. So in the y equals kx format, k is now going to be a 2. My y value stood for like dollars, so I'm going to use d for dollars. And x value here stood for pounds, so I'm going to use p for pounds. So d equals 2 times p. And number 4, it costs $15 to send 3 packages through a certain shipping company. All right, and we like to put money on top here. We want to find our constant proportionality. So $15 over 3 packages. So y over the x, and divide that, and I get $5 per package. And if I get my equation set up, y equals k times x, the k is going to be a 5, and the y I changed to a d because d stands for dollars, and the x stood for packages, p stands for packages. All right, we got one more problem to kind of look at here. It says Allison's middle school team has designed t-shirts containing their team name and color. Allison and her friend Nicole have volunteered to call local stores to get an estimate on the total cost of purchasing t-shirts. Printorama charges a setup fee as well as a fixed amount for each shirt ordered. The total cost is shown below for the given number of shirts. Value Tees & More charges $8 per shirt. Which company should they use? Now I'm going to help you out here on the Printorama stuff. It's kind of a hard problem to figure out otherwise, but it's going to be a $25 setup fee. So if I'm to design the shirt, it's going to be $25. After that, it's $25 per shirt. So that's kind of the basic format though. So if you want to get 25 shirts, you just take 25 times 7, then add $25 more to it. So if you want to get 75 shirts, for example, you take 75 times 7, and you just add $25 to that. So that's kind of how those numbers got filled out. But it was kind of a tough problem that I always helped the kids with in class. And value tees and more, we can tell this is going to be a proportional relationship. You can see you're going to have a straight line, it extends down into the origin. So we'll get to that in just a minute though. Does either pricing model represent a proportional relationship between the quantity of t-shirts and the total cost? Well, yeah, value tees definitely is going to have that because they were always at a constant rate of $8 per shirt. It told us that in the instructions. So value tees will have that. Now I'm going to do C next because I want that constant proportionality before I do an equation. What's the constant proportionality for value tees and more? Well, if you look at any of your points, you can figure that out. Take your y value divided by your x value, 80 divided by 10, 160 divided by 20, and so on. You're going to get $8 a shirt, which we already knew anyways. They already told us that. Now, I want to take that y equals kx format, and the y here stood for cost, so I'm going to use C for cost, and x was going to be t-shirts. See, my x label was the number of t-shirts, so I'm going to use T for t-shirts. So instead of y equals kx, my k turns into 8, y is going to be the cost, so I got C, and the x is going to be t-shirts, so I put T. And how much is Printerama setup fee? I already helped you with that. It was going to be $25. Now, our last one. If you need to purchase 90 shirts, we got to figure out who has the better deal. So, Printerama, we already told you up above, it was going to be $7 a shirt. 90 times 7, and then we have to add that $25 fee, so $655. Now, value tees was always going to be $8 a shirt, so 90 times 8 equals $720. So if you're purchasing 90 shirts, Printerama is the better deal. It's going to be cheaper. All right, thanks for watching, and hopefully you get off to a good start building equations.